Welcome back from the ad break, and let's continue with our lesson. So now we are going to be looking at the first part of our concept map, and that is the types of triangles. So let us look at the first type, which is the equilateral triangle, and we are going to be looking at the sides of this equilateral triangle. Triangle ABC is given below. What information can you gather from this triangle? So we can see that we have been shown that there is equal sides here, and that is the symbol that we use to show that the sides are equal. So what does this mean? This means that AB is equals to AC, and that means that AC is also equal to AB. So an equilateral triangle, all the sides are equal. In triangle PQR, PR is equal to 5 centimeters. Determine the length of sides PQ and QR. Now, if we look at the triangle that we have been given, we are given information that side PR is 5 centimeters. But something more is given in this diagram. So we are shown that PR is equals to PQ, and that is equals to QR. So we are shown there that those three sides are equal. Now what does this mean? It means that PR is equals to PQ, and which would mean that PQ is also equals to 5 centimeters. Now, how do we know this information? It's because our diagram has given us that information. So we know that these two lines are equal because it has been shown to us that these two lines are equal. So we have calculated the length of PQ. What about the length of QR? Now, again, looking back at our diagram, we can see that QR is also equals to PR. So PR is equals to our QR. And again, they are both equal to 5 centimeters each. And where do we find this information? We know this because it was given to us, shown in the diagram that the lines are equal. Let's move on to the next type of triangle. The next triangle that we are looking at here is an isosceles triangle. Now, we are also going to be looking at just the sides here, but an isosceles triangle is, let's look at the following isosceles triangle and see what information we can gather with an isosceles triangle. So, triangle PQR is given below. What information can we gather from this triangle? Now, when we are looking at this triangle, again, we've been shown those symbols that we use to indicate our equal sides. So from here, we can see that PQ is equals to PR. And this is now an isosceles triangle. How do we know that it's an isosceles triangle? It's because two of the sides are equal. Now, remember, with an equilateral triangle, all of the sides were equal. Now with an isosceles triangle, it is only two sides that are equal. As we can see that it's shown here that PQ is equals to PR. So with an isosceles triangle, we know that two of the sides are equal. Let's go on to looking or calculating lengths in an isosceles triangle. Now the following triangle is an isosceles triangle. Determine the length of DE. So again, an isosceles triangle is a triangle with two sides that are equal. And here in this triangle, we have been shown that DE is equals to DF. And since as well we have been given that DF is equals to 8 centimeters, that means that also DE is equals to 8 centimeters. And all of this is because we know that this triangle DEF is an isosceles triangle. Let's move on to the next type of triangle. Now, the next type of triangle here is a scalene triangle with no equal sides. So a scalene triangle has no equal sides at all. That means that this side and this side and this side are all not equal to each other. So there are no equal sides. LM is not equals to MN, and MN is not equals to LN. Let's look at right-angled triangles. So a right-angled triangle is a triangle that has one of the angles as 90 degrees. A right-angled triangle can be an isosceles triangle, or it can be a scalene triangle. Do you remember what an isosceles triangle is? It is a triangle that has two of its sides equal. So if we look at the the triangle here on the right hand side, we can see that it is a right angle triangle because we have been shown that symbol that indicates to us that that is a 90 degrees. So we can see that it's a triangle. We can see that one of its angles is a 90-degree angle. And we can see that we are shown that AB is equals to AC. So this is an isosceles right-angled triangle. It's a right-angled triangle and it's an isosceles triangle. Now looking at this triangle on the left, which also has a 90 degrees, which means that it is a right-angled triangle. But we know, or we can see, that all of the sides are not equal. Now, if the sides were equal, or if there were equal sides, we would have been shown or told in our statement that certain sides are equal. So since as well that is not there, or that is not shown to us, that means that none of the sides are equal. It is still a right-angled triangle, but a right-angled scalene triangle because none of the sides are equal. Let's look at an example. So we have this example here, and it says there, the following triangle is a right-angled triangle. Determine the lengths of AC. Now, of course, we know that with a right-angled triangle, if we are looking at the sides, then we can use Pythagoras to solve the sides that are unknown. And since as well we have two sides here, we were given AB, which is 6 centimeters, and BC, which is 8 centimeters, and we can see that it is a right-angled triangle. That means we can find AC, which is the hypotenuse, but we can find it using Pythagoras. So that is AC squared is equals to AB squared plus BC squared. And the reason why we are using this statement is because this is the Pythagoras theorem. Now remember, the Pythagoras theorem only works if a triangle is a right-angled triangle. So AC is the one that we are looking for. So we are going to say AC squared is equals to 6 centimeters squared, that is the length for AB, and 8 centimeters squared, that is the length for BC. So AC squared is equals to 36 centimeters squared. That is 6 centimeters multiplied by 6 centimeters. And we are going to add 8 centimeters squared, which is 64 centimeters squared. And when we add these two together, we are going to have 100 centimeters squared. So that is 36 centimeters squared plus 64 centimeters squared. So now we have AC squared is equals to 100 centimeters squared. Now, what number is squared and gives us a result of 100? Yes, if you are thinking that AC is equals to, so if you are thinking that AC is equals to 10 centimeters, then you are correct. You are correct, because 10 centimeters multiplied by 10 centimeters gives us 100 centimeters squared. So this means that the length of AC there is 10 centimeters. And we found that missing length there using Pythagoras, because as we can see, this triangle is a scalene triangle. None of the sides are equal, which means that we need to use other methods that we have previously learned to solve for missing or for unknown sides. Let's quickly go to an ad break, and then we'll see you just now.